Welcome to a walk through one of the most closely watched moments of CES 2026, the opening keynote delivered by AMD's chair and chief executive, Dr. Lisa Su. The theme was simple to say and enormous in scope: AI everywhere, for everyone. And over the course of the keynote, Lisa Su laid out how AMD's portfolio, from the largest data center racks down to the chips in laptops and robots, is meant to turn that promise into real-world impact. She was joined on stage by partners spanning frontier AI labs, healthcare, space, and government. What follows organizes the announcements by theme, moving from the giant infrastructure at the top of the stack down to the edge, and finally to AMD's push to widen access to AI itself. The yotta-scale era. Lisa Su framed the entire keynote around a shift in the sheer scale of computing. Compute infrastructure, she argued, is the foundation of artificial intelligence, and adoption is now driving an unprecedented expansion, from roughly 100 zettaflops of global compute capacity today to a projected 10 or more yottaflops within the next 5 years. A yottaflop is 1,000 times a zettaflop, so this is a leap of orders of magnitude, driven by relentless growth in both training and inference. Her central claim was that building for this era takes more than raw performance. It demands an open, modular design that can evolve across product generations and connect thousands of accelerators into a single unified system. That framing, that we are entering the age of yotta-scale computing and that AMD intends to build its foundation through end-to-end technology, open platforms, and deep partnership, set up everything that followed. Helios, the rack-scale blueprint. The flagship reveal was an early look at the AMD Helios rack-scale platform, which Su described as the blueprint for yotta-scale infrastructure. A single Helios rack is designed to deliver up to 3 AI exaflops of performance, engineered for maximum bandwidth and energy efficiency so it can handle the training of trillion-parameter models. What makes Helios notable is that it is a complete, integrated system rather than a single chip. It is powered by AMD Instinct MI455X accelerators, paired with AMD EPYC Venice CPUs, and knit together for scale-out networking by AMD Pensando Vulcano network cards, with everything unified through the open ROCm software ecosystem. In other words, AMD is now competing not just at the level of individual GPUs, but at the level of the entire rack, the same battleground where the largest AI systems are actually built and sold. The full Instinct MI400 lineup. For the first time, AMD unveiled the complete Instinct MI400 series accelerator portfolio. The newest addition is the AMD Instinct MI440X, a GPU built specifically for on-premises enterprise AI. It is designed to power scalable training, fine-tuning, and inference in a compact 8-GPU form factor that slots into existing infrastructure, a deliberate answer to enterprises that want serious AI capability inside their own data centers rather than only in the cloud. The MI440X sits alongside the previously announced MI430X, aimed at high-precision scientific computing, high-performance computing, and sovereign AI, and the MI455X that anchors the Helios rack. Together, they give AMD a full ladder of accelerators, from the frontier training rack down to the enterprise server closet, powering sovereign AI supercomputers. Su grounded the MI430X in concrete, already committed deployments, which is what separates a keynote slide from a real product. The MI430X is set to power AI factory supercomputers around the world, including Discovery at Oak Ridge National Laboratory in the United States and the Alice ROCm system, France's first exascale supercomputer. This is the sovereign AI story that has become central to the industry. Nations and national labs want the ability to train and run frontier models on their own soil, on hardware they control, for science and security alike. By naming flagship systems on 2 continents, AMD signaled that its top-end accelerators are not merely competitive on paper, but are being chosen for some of the most demanding public computing projects in the world. The road to MI500, 1,000-fold by 2027. Looking further ahead, Su previewed the next-generation Instinct MI500 series, planned to launch in 2027. The headline claim is striking: The MI500 is on track to deliver up to a 1,000-fold increase in AI performance compared with the MI300X that AMD introduced back in 2023. That figure comes from AMD's own engineering projections and refers to a full MI500 powered rack measured against an earlier MI300X platform. So it is a system-level, forward-looking estimate rather than a shipping benchmark. But the ambition is clear. The MI500 will be built on AMD's next-generation CDNA 6 architecture, advanced 2-nanometer process technology, and cutting-edge HBM4E memory. It is a reminder that in AI hardware the roadmap is the product. Customers are committing years in advance, and AMD is signaling a cadence meant to keep pace with the frontier. The AI PC, Ryzen AI 400 series. From the data center, the keynote turned to the device most people actually touch. AI, Su argued, is becoming a foundational part of the PC experience, with billions of users interacting with it both locally on their devices and through the cloud. To serve that, AMD introduced the next-generation Ryzen AI 400 series and Ryzen AI Pro 400 series platforms, which deliver a 60 TOPS neural processing unit. TOPS meaning trillions of operations per second, along with strong efficiency and, notably, full ROCm platform support so that AI work can scale seamlessly from the cloud down to the client. The first systems ship in January 2026, with broader availability from computer makers through the first quarter. It's a bid to make every new AMD-powered laptop a capable AI machine out of the box. Big models on your desk. The most eye-catching client announcement was about running genuinely large models locally. AMD expanded its on-device compute lineup with the Ryzen AI Max Plus 392 and Ryzen AI Max Plus 388, which support models of up to 128 billion parameters using 128 gigabytes of unified memory. That means advanced local inference, content creation workflows, and high-end gaming inside premium thin and light notebooks and small form factor desktops, without sending your data to the cloud. Su then extended the story into what AMD calls physical AI, intelligence embedded in the machines around us. The company introduced the Ryzen AI Embedded processors, a new portfolio of embedded x86 chips built to power AI-driven applications at the edge in the most constrained systems. The new P100 and X100 series are aimed at everything from automotive digital cockpits and smart healthcare devices to autonomous systems, including humanoid robotics. This matters because the next wave of AI is not only about chatbots in the cloud. It is about perception and decision-making running efficiently inside cars, medical equipment, factories, and robots, where power and space are tight and reliability is everything. The partner ecosystem. A keynote like this is also a show of gravitational pull, and AMD brought an unusually broad set of partners on stage to demonstrate real usage. Frontier AI labs and tooling companies were represented by OpenAI, Luma AI, Liquid AI, and World Labs. Blue Origin spoke to space and advanced engineering. And a striking cluster came from life sciences and healthcare, Generative Bionics, AstraZeneca, ABSci, and Illumina, showing AI applied to drug discovery, genomics, and human health. The message was that AMD's hardware is not a closed island, but the compute foundation beneath a wide ecosystem, and that the interesting breakthroughs increasingly happen where that compute meets a specific domain. The Genesis mission and AI for everyone. Su closed on the for everyone half of the theme, and here the keynote turned to government and education. She was joined by Michael Kratsios, director of the White House Office of Science and Technology Policy, to discuss AMD's role in the United States government's Genesis mission, an ambitious public-private initiative aimed at securing American leadership in AI and accelerating scientific discovery. Genesis already includes 2 AMD-powered supercomputers at Oak Ridge National Laboratory, named Lux and Discovery. Kratsios also highlighted a broader push to expand access to AI education. And in joining that pledge, AMD committed $150 million to bring AI into more classrooms and communities. Fittingly, the keynote ended by recognizing the more than 15,000 student innovators who took part in the AMD AI Robotics Hackathon, run in partnership with Hack Club, a closing note that tied the yotta-scale ambition at the top of the stack back to the students who will actually build the next era.